Hi, my name is Alex Holachek, and today I want to talk to you about building mobile-friendly React apps. I hope you get two main things out of this talk. First, it's going to be a reminder of a few 201 level aspects of mobile web UI. So we're not going to be talking about really simple things or more basic things like the meta viewport tag, but we're also not going to be talking about anything particularly advanced. And second, I want to introduce you to some tools that you might be interested in to make your mobile web development workflow a little bit easier. Full disclosure, I worked on these tools and made them, so it's a little bit self-promotion, but if you're not interested, you can scrub past those parts in the talk. The impetus for this talk was actually a quote that I have here, and the story of this quote is that I gave a talk last year at ReactConf about building beautiful native-like mobile web animations. And I was telling my friend about it and saying, how exciting it had been to give the talk and talking about what I had discussed. And she said that the mobile web is janky and native apps are better. And she said, I don't like designing for the mobile web. Now, of course, my feelings were a little hurt, but more importantly, I was thinking this was kind of an interesting point because I'd heard similar thoughts coming from other people. And I thought maybe it would be a good avenue to explore a little bit. Is the mobile web inherently janky? What can we do about it as web developers? And I guess taking a step back, what does it even mean for something to be janky in the context of the mobile web? So I've decided through some research that I think jankiness on the mobile web can sort of be divided into two categories. And it's important to state, I think something that's janky isn't necessarily broken. So a prerequisite is that it actually works for it to merit the title of janky. But the first family of issues, I guess, are that something is difficult to interact with. So this might be in terms of tapping, form inputs, scrolling, I'm sure other things as well. But then the other subset of jank issues are speed related. Either the app loads slowly or it responds slowly to user input. Those can all be frustrating and make it feel like we don't have full control over the experience. I don't think it's a coincidence that these two classes of issues, looking at taps and scrolls and gestures, and speed, that these two classes of issues are harder to reproduce with a mobile emulator. So it's really easy to release code that seems fine on desktop, but it seems janky on mobile. So let's look at a little closer at some of these issues and how we can avoid them going forward. And today I'm just going to talk about two specific things in terms of interactions, tap interactions and forms on mobile. So you might be thinking, okay, so tap is really boring. I don't really necessarily want to sit in on a talk about tapping on mobile. But I think it's a little more interesting and a little more nuanced than you might think, or that I thought when I was first looking into it. It's not just a one-to-one correspondence with clicks on desktop. So before we get into talking about how tap states work, let's just get you thinking. So here's a quick quiz about tap states. What's the maximum amount of time that we can wait to respond? I should say I live next to a train, so you might hear the train on occasion during this talk. What's the maximum amount of time that we can wait to respond to a user interaction and still create the impression of instantaneous feedback? What CSS pseudostates like hover and active are applied when you tap a button in iOS? And finally, why might you want to delay applying a tap active state when an element is first pressed? Right, so with those kind of questions percolating, let's take a look at default tap states on iOS and Android. On iOS, there's a default gray highlight. It appears on tap and disappears as soon as tap ends. It does not show up on scroll. And because it disappears quickly, there's no persistent visual indication that a tap has occurred if the UI blocks. And I have this little test app that we'll see for the next few slides, and it purposefully blocks on every page by running a bunch of JS before it renders the next page. The story on Android is pretty similar. There's a default blue highlight this time. it only really registers on longer taps, so it's easy to do taps without getting any indication at all. It does not occur during scrolling behavior, and it's generally a square. I was unable to change it into any other shape, at least. So that's the default situation. In an ideal world, what would we like to see for tap states? We'd want a custom style. We'd want a persistent active state until the next tick of the UI, the next render, I suppose. And we'd want some customizability so that elements in high traffic areas would have a longer tap delay, and items that are unlikely to be accidentally pressed would highlight immediately. So you might be thinking, can't we just add active styles with CSS? And that was the next thing that I tried when I was looking into this. I tried something like this. So I disabled the native or the default tap highlight color and added some active styles. But this isn't necessarily a good solution either. So first of all, active states will only work on iOS if we attach a touch listener somewhere on the document, or somewhere on the, I guess, the parent of the element or the element itself. We still don't get that persistent indication that I keep talking about. And even worse, there's an immediate application of styles, which means you're constantly inadvertently triggering active styles, even if you're just scrolling or swiping. And that might not be such a big issue on a nav, but look at something like this. I made a little demo. You're on some hypothetical banking app where you've gotten into a situation where you're about to transfer $1 million to CoolCore, which you do not want to do. So you're scrolling down the page to try to find the cancel button, but you're triggering the active states for all the buttons before. So you're having like a mini heart attack when it appears that you've triggered the confirm trade button. And if we're triggering hover and active states willy-nilly, when the user hasn't actually triggered a click, they're going to mean less than if they show the user that an action is about to be taken. So we want to make sure this doesn't happen. In Android, the default active pseudostate is a little nicer. It has a delay, so it's not activating immediately. You have to tap and hold to get the active state styles to appear, so they're not always there, which is kind of a drawback. And you still don't get that persistent indication that something has happened. We can use a little bit of JavaScript to solve the problem. We're going to standardize the active style delay to 0 milliseconds, and we're going to make sure the active styles are removed immediately if the user swipes or scrolls. And finally, we're going to make sure they remain until the next update of the UI. And here's how we're going to do that. First, hover and active styles are going to be limited to desktop or to non-touch devices, let's say. So we're going to do that with this pretty well supported media query called media pointer find. Next, we're going to toggle a class or a data attribute. And then when that class is applied, we're going to put our own delay back in and standardize it across platforms. Here's like the simplest implementation that we could use, a little hook called useTapActive that toggles an isActive state variable, and it returns some touch listeners that will toggle that variable on and off. And here's how you might use a hook like this. Just spread the listeners into the element and use the isActive state variable to toggle some classes. That works, and I think that's the way some companies do it, but it's a lot of ceremony, and I can see myself forgetting to do it. So I made a hook that instead sits at the top of your app and uses event delegation to register a single listener, and maybe acts a bit more like a polyfill. So this listener will toggle a data tap active attribute for elements with a data tap prop. I have a sample clue box here. And here's my use tap toggle hook. It's only about 60 lines. I'm not going to go into it too much, but if you're interested, please fork this sandbox, check it out. Maybe you can, I have a bunch of different components here so that you can test different tap styles. Maybe you can find better styles than I did, or better ways of dealing with them. But anyway, so that tap toggle hook we looked at, this is how you would use it. You would just call it once in the top level component, and any component that needed tap styles, you would add a data tap attribute, and you'd use that to style the element. So we'd go here, we'd add our custom styles, And importantly, now we can add a transition delay so we can decide to not show the styles for some set amount of time to prevent inadvertently triggering them. In this case, it's 60 milliseconds, which I found tend to work pretty well. You might want to go up to like 80 milliseconds, which also worked well, and minimize the chance of accidentally triggering the styles. Obviously, this is predicated on the style you want being CSS animatable, which is not true for all types of styles, but it's true for a lot of them. Yeah. Yeah, and so if we apply some JavaScript and some CSS like that, we get to a pretty good state. This largely satisfies everything that we wanted. Sure, depending on the timeout, we still might accidentally trigger a few elements, the active state on a few elements, but it's going to happen a lot less, and there's going to be more consistency across iOS and Android for our site. And it creates a nice user experience that gives you sort of confidence that you've done what you meant to do when you clicked on a nav item. So in review, for best customizability and cross-platform performance, it makes sense to apply and remove tap states with JavaScript. We need to strike a balance between applying the tap state fast enough for responsiveness, which is 100 milliseconds. I think that was a quiz question that I never directly answered, but there it is. But not so fast that the user accidentally triggers it when making another gesture like scroll. And ideally, tap states should remain present on an element until the action desired by the user has triggered a UI update. So that was tap states. Now let's take a quick look at form inputs. Here's another pop quiz. What's the main difference between input type text and input type tel on mobile? Why would you want to use input mode decimal attribute over input mode numeric? And finally, what autocomplete value should you use for new password inputs? So until fairly recently, when I created a form, I would make sure that it fit well on mobile, but would essentially consider my work done once it worked well on desktop. But we really have to think about a few extra things for forms on mobile. And just like tap and desktop or mouse clicks, those are like very different things that require different techniques and awareness of their differences. Using the keyboard on your laptop or your computer, it's very different from using the keyboard on your mobile device. And so basically, because this is something that's easy to forget when you're developing, I made a little tool to make it hopefully easier to preview different configurations. Different configurations. I think there was a little glitch in my video recording. But anyway, it's here at buildbettermobileinputs.netlify.com. And let's take a look. So basically we have some HTML5 input types here. And we can just go through them and see what keyboard that's going to bring up on the right here for both Android and iOS. And this is really important because some of the keyboards aren't too different, like search and text, but some of them, like text and tel, are quite different. And they're going to make it easier for the user to input their information. We also have some kind of interesting date inputs that look really different on Android and iOS. I haven't really used these intensively, but it's good to know they're there, I guess. There's also input mode, which allows you to override the keyboard that's being shown. I haven't found too much of a use for this other than input mode decimal, which creates kind of a better version of input type number. Of course, it's not a one-to-one comparison, but it gives you these really nice number keyboards on iOS and Android and avoids some of the issues with input type number. And just to highlight something that I thought was interesting, input mode numeric is a little different. It's the same on Android as input type decimal, but it doesn't offer the focused numeric focus number keyboard that input type decimal does. So I like using that. And then finally, looking at autocomplete. It's easy to forget adding an autocomplete field to our form inputs, but it's really important, and the browser heuristics don't always pick up or always figure out what the appropriate autocomplete field is to use. Anytime we can minimize typing for our users, obviously we can make it easier for them to complete their forms. And there are just so many autocomplete options that you might not be aware of. I certainly wasn't until fairly recently, and it might be good to review them. A few that I have found interesting are autocomplete new password, which you can definitely tell when sites don't use it. When you're trying to change your password and it autocompletes your current password, that means they didn't use autocomplete new password. There's also one-time code, which makes like a phone verification flow much easier, and there are various other ones. So I think autocomplete is generally very helpful. I will say that, of course, sometimes you want to turn it completely off. There's autocomplete off here, but that's ignored by Chrome, I think. So what I tend to do is put a semantic autocomplete value that I've just made up myself, and that generally turns it off for me, but I know that there's some back and forth about whether that always works. All right, so that's autocomplete. And that's what I wanted to say about forms. Now, forms and TAP, we've talked about two specific things, but obviously there's a lot more CSS, HTML, UX design stuff that we can be doing, and there's not really time to go through all of it. So with that in mind, I created this Storybook add-on called Storybook Mobile. And basically what that does is it gives you some of those tips and tricks that you might know, but in crunch time, it might be easy to forget to do some of this stuff. So if you have this Storybook add-on, my hope is that it foregrounds some of this information as you're building and makes it easier to do the right thing in terms of mobile friendliness. Here's an example that I have linked to in the README. You can see that there are warnings and hints. So warnings are things that you might want to change, and hints are more like, hey, did you know this thing exists? Let's see, our warning for this form is looking at some tap targets that are too close together and too small. It's warning you about the absence of autocomplete, a large image without the source set attribute, suggesting maybe looking at keyboard changes, and 100 VH. And there's a few other things like active styles, overflow scrolling touch. Yeah, a few other things that might prove helpful. And this add-on is very new, so I'm still in active development. And please make an issue or suggestion if you have one. So that's Storybook Mobile. And now we're going to move on to the speed section, and I'm going to go pretty quickly through the speed section. So with a wide range of CPUs and network conditions, the mobile web is a lot less forgiving than desktop in terms of performance. I don't think this is new information for anyone, but people are going to bounce if your web app is slow. I really love these three tools. I use them a lot, and I use them because they're very easy to use. It's like, it's not a big effort to use them. Lighthouse, React DevTools, the Chrome DevTools Performance Panel, and I think those are quite popular and give you good views on the performance of your web app. So before we move on to another tool that I want to talk about, I want to do one more pop quiz, which is about your web app or a project you've worked on recently. So what's your biggest node module dependency? What's the relative size of your bundled first-party JavaScript versus your third-party scripts like trackers? And finally, which of any of your bundles reliably trigger main thread blocking long tasks when they load? So I made a tool to make it easy to answer these questions, and maybe even fun to answer these questions about what JavaScript you're shipping to your clients, basically. And what this tool is basically a wrapper around Source Map Explorer that gives you a lot of information about a specific entry point of your app. And I'm going to demo it by running Bundle Wizard on the React Europe website. So let's say Bundle Wizard React Europe.org. So what this is doing is basically using Puppeteer to load the site. It's going to download the JavaScript, both the bundles and the third-party scripts. It's going to look at coverage information, source maps, and it's going to record performance information. and it's going to show you a visualization that should be pretty familiar to you if you use Source Map Explorer already. Okay, here it is. So here's our visualization. By default, it will show you third-party scripts and JSON. It looks like YouTube is a big dependency as a third-party script, but if we want to zoom into the more like the Webpack bundles and stuff like that, we can do that by removing those. So here we have, it's like 1, 2, 3, 4, 5, 6 bundles, and we can drill down and see what actually made it into the bundles. The graph by default is a simplified view, so you can toggle that on and off, and it's showing us coverage. So basically, the green code was run by the browser, and the red code was not run, or maybe only a little bit of it was run. And if you see big groups of red, you might be able to chunk that out. Another thing you can do is look actually at the code. So you can click on any of the boxes to see what code was sent down, which can be helpful as you look around and see what's there. Pretty interesting. Finally, yeah, the last thing is that there's a little alert that pops up if the bundle triggered a long task when it was loaded. And unfortunately, that's only moderately useful because you don't really see why that happened, but you can go to the dev tools, like Chrome DevTools, and run a performance profile and then dig in a little deeper to like what was kicked off that created the long task. Yeah, so there's a summary tab here that I won't go on into too much, but that's basically what Bundle Wizard can do for you. You know, if you have a bigger app, you can check the sign up page, the login page, other different entry points, and compare them, because it will download only the bundles that were used to build that page. Oops, and that's the project, Bundle Wizard. If you want to check it out, and of course I would love feedback. All right, so that's my talk. And in conclusion, if we want to protect our React apps from being called janky on mobile by our designer friends, we have to go beyond simple responsive design. We need to pay attention to the ways that user interactions on mobile are very different from interactions on desktop, and how we can support those and make them really smooth. Finally, nothing beats checking our work on real devices to catch issues before they get into the hands of our users. And probably maintaining that as a habit is the most valuable thing that we can all do. And yeah, so I appreciate you making it to the end of this talk. And here are the list of projects that I talked about. Thanks.